So I think we'll just start off. Again, thanks a lot for joining in, everyone. And so this particular masterclass is part of the Glocal Evaluation Week that is being hosted by Clear and JPAL team across the globe. And a lot of work that people do across the globe focuses on monitoring and evaluation. And one of the core agenda about this year's theme is also using AI into evaluation and monitoring as well, right? So this masterclass is being hosted by Catalyst Management Services from Bangalore in India. CMS has been in the space for social impact for about last 3 decades, largely looking at the monitoring and evaluation across different domains in India and also Southeast Asia, plus another 20 odd countries across the world. And across all these years, we have sort of uh, come up with innovative products slash platforms where we have been able to implement these tools into different contexts, starting from, let's say, the disasters to child protection to climate to health and education and all those cross-cutting domains as well, right? And as part of the last 4 5 years work at CMS, I basically call it the data science and tech team at CMS, where larger focus has been on innovating use cases around data science in the space of monitoring and evaluation, right? Are there any new use cases that we can sort of find out with the evaluation of AI in the world right now? And how can we leverage this AI more effectively for helping different social impact programs across the globe? So that has been the larger focus in last 5 6 years at CMS, specifically in the data science unit, and we have been able to implement this across different contexts of, let's say, governments, philanthropic foundations, CSRs, and likewise, right? So today's masterclass will largely be focusing on one particular use cases of AI, which is called event-based monitoring, which allows uh, signals or unstructured data to be converted into more of an insights where we are able to use that for a real time decision making, right? So I have my colleague also joining in, Sachin, who is a senior associate at CMS, and he's the one sort of leading this entire initiative in the CMS for last about 3.5 4 years, and have been developing this along with the larger team who is sort of implementing across different instances, right? So I'll just give a bit of context on how does this entire event-based monitoring works, right? So what is actually the event-based monitoring? Because all of us today understand, if you can go to the next slide, Sachin, we understand that as part of the M&E, a lot of time we collect data. We also come across a lot of unstructured data on the ground. There are different, let's say, qualitative insights, a lot of interactions that we happen on the ground with the communities. Then there are news reports which sort of flags, okay, there are certain, let's say, events that are going to happen in the future. There are already events that are happening in the current reality, right? But all of this remains fragmented across different sources and don't get converged to a point where a program or any institutional stakeholder who is operating in that environment is able to make decisions, right? So there is certainly an opportunity where we can convert all these different signals that are emerging from various contexts, which are in near real-time basis, right? Because a lot of this work is already happening and people have started reporting. How can we use that to convert into something of an intelligence that program people can use, right? That is where the premise of entire event-based monitoring came in. Just to give a bit of context, let's say when we are doing this during the COVID time, that's almost 5 years back, we realized that a lot of today's outbreaks are dependent on the events that are being reported in another country or another location, right? So let's say when I'm staying in Bangalore, probably geography getting affected in near Bangalore might affect me as well in future. But having that intelligence can help me prepare myself and my own institutions much better, right? So that's where this entire event-based monitoring as a concept came. Now I'll just briefly explain about how does event-based monitoring works in the next slide. So let's say we know that, okay, there are events which are happening in across different contexts, right? Now it could be a disease outbreak, it could be a conflict between, let's say, human animal, it could be, let's say, service delivery failures in different parts of the world, it could be changing in the policies, it could be different institutional stakeholders who are sort of working on a let's say ecosystem building, all of that, right? Now a lot of that gets tracked at various point in time in different forums, different media, different channels, all of that, right? But all of this stays in isolation. So I'll give you an example. During COVID time, certain things used to come in, let's say Twitter, certain things used to come in news media, certain things were coming from our own community institutions where we work very closely, right? All this has a certain pattern to it. There are locations, there is a date or temporal or spatial nature to all the information that are being generated in these different events. Now, how are we able to extract specific intelligence out of all of these signals and able to convert into something which is consumable for different programmatic implications, right? That is where the entire event-based monitoring tool comes into play. And based on this intelligence, the actors are able to act on the field, able to provide the right services, able to act in time, prevent the disease outbreak and all of that, right? So the idea is that we are not trying to replace the survey or MIS or an evaluation, because that also has their own purposes. But what this event-based monitoring helps us is with allowing a near real-time intelligence, so where you do not have to wait for another survey to happen. So if we look at in the next slide about how it sort of differs from the traditional monitoring setup, right? All of us know that in current monitoring setup, even with the tech, in a few cases which technology is available, a lot of time the reporting happens in a periodic nature, probably a week or a quarter or a month, all of that, right? And it also depends on a structured forms, certain indicators and all. But a lot of time the insights come from the qualitative interactions, a lot of things which are beyond your even catch, right? Because let's say if I'm operating in a one particular district in Uttar Pradesh, the same things might be happening in probably another district in West Bengal, but I'll never get to know about it unless I have this intelligence saying that okay, the same thing can be acted upon in my district as well, the same way it has happened in West Bengal. That's an intelligence being lost in the sector, which should be available for more effective, let's say, the activities on the ground, right? So what event-based monitoring allows is to capture near real-time events, allow allow us to extract the insights and the actions or knowledge out of it, able to help that okay, whatever data is being reported on the ground, support them, help them triangulate with the right quality checks, validation and all of that, and able to generate pattern which are specific to either the location or a specific to a context, environment, all of that put together, right? So what we'll do in this masterclass is also to focus on specific approach on how this entire event-based monitoring gets applied in various contexts. We'll take one specific use case of public health where we have done this. It has led to certain outcomes in terms of the institutional adoption and how it has helped in preventing the outbreak as well. So we'll go through this entire journey, and at any point in time, I'll also request participants to sort of ask question, engage wherever they feel that they need more clarity. And at this point, I'll invite Sachin to sort of walk us through the entire journey of how event-based monitoring has been developed. Yeah, over to you, Sachin.
Yeah, thank you, Kiran. And thank you all for joining us. I'll touch upon more on the logic side and on the technical side, how the system is implemented and can be implemented for different use cases. So, on a high level, if we see how this entire process works, we collect all the data that is out there, remove the noise, add context, and support decisions. Right. So, just to let touch upon each of these points in detail. Data is always out there. So the problem is not availability of data, it is more on how you use it. So when we collect signals from the web, we collect pretty much whatever is available. Our focus is to look for things that we intend to act on. So in this case, if you look at the public health example, we want to look at how outbreaks can be prevented before they even become an outbreak in the first place. So we look for things that not only have shown that outbreaks have happened, but also triggers for these outbreaks. So these are the signals that we look to collect. And after you do that, you have to make sure that you're getting the right information, which is where step 2 comes in, where you filter for only information that is relevant to your use case. So if I were to give you an example of that, an outbreak can mean multiple things in different contexts, right? So, how do you filter out what is a public health outbreak versus what is an outbreak in a different context? Is where your intelligence layer comes in and it acts on data that you give it. So, what that means is you train your models to identify what is relevant to your use case versus what is irrelevant, and that is the filtration layer that removes this noise. Then you proceed to do things that enrich the quality of the relevant data that you have and make it easy for your program teams to consume and act upon. So some of these include, of course, identifying what exactly has happened, where it has happened, which is the location part of it. Then what is the factor that is contributing to this particular event? So in our case for public health, we look at the entities, which is the disease that is causing this outbreak. But in different contexts, we also look at different kinds of entities. So entities are flexible and domain agnostic, but you can custom tune which entities you want to capture. Then along with that, you also look at how severe is this event based on either the sentiment or different parameters that you define. So let's say in public health, maybe the case count is it defines a severity, right? So that is another layer of intelligence that you can add, where you see not only what has happened and the details of the what side of things, but also how bad it is. Um, and that really allows you to tailor your action according to that, because it allows you to prioritize different events, and not all of them may need your attention. So this just helps alleviate that problem. Then, of course, you want to aid your program team as much as you can. So we create an interface for them to interact with this data and use their own domain knowledge and their own background to act upon it and to see things that maybe some of us will not be able to see. So kudos to our public health team for what they do after this stage is over from our side. And one principle you can see at the bottom is that the taxonomy is program specific, right? And what that means is we want to look at only things that pertain to their program. But at the same time, the interface should be designed in such a way that it should answer the questions that they want to see answered. If it is too broad, then it is as good as going out on the web and doing everything from scratch. So to avoid that problem, we try to answer their questions through the interface. So if you want to look at the technical layer, right, which is sort of a deep dive on what we just covered, the approach that we just looked at. The first thing that you need to do is define the search universe, which means specify what exact signals you're looking for, specify what geography, and even specify things like what sources you prefer it from. The sources may not be like an exact source. It can also be so types of sources. So, for example, maybe you don't want to look at blogs being posted. Maybe you don't want to look at what everyone's saying on social media. You want proper vetted sources. Maybe you want videos. Maybe you want just text, or maybe you want official reports from the government that are coming up. So this is where you specify exactly what you're looking for, and you can even keep it vague if you wish to capture everything and then filter it out later on. But this is the crucial process because this defines what comes into your system. Then you look at okay, after specifying what I want, and when everything is coming into my system, you look at what exactly is the content of what is coming in, and you look at how do you structure this in such a way that you can store it efficiently, you can query it efficiently, and you can generate insights out of all this data, which may not be the same format, may not be the same types of content, and how do you trace it back such that you know what the ground truth was compared to what your interface shows. And then the removing noise part we spoke about in the previous slide, but and we'll also see how this is implemented in multiple phases going further. And then you also want to make sure that you want to capture things at a hyper local level, which is where things like translation and all that come in. So that you are not only fed information that would normally form into your universe, but also things that you would have otherwise never looked at, which includes things like, let's say, for example, sitting in Bangalore, you will not look at something that's happening in Meghalaya or something that's happening in some rural village somewhere, because language itself is a big gap for you. So, translating and getting those hyperlocal data points is where you are exposed to a new scenario that your eyes were otherwise closed to. And if we look at another layer in this entire architecture, one is the entity extraction that I was talking about. So you look at diseases, you look at locations, you look at symptoms. So symptoms are identified based on a large corpus of text that the models that we use have been trained on. So let's say fever or headache, for example, could be a symptom of a larger disease. So although the disease itself has not come into that particular location. Just the fact that these symptoms are showing up more often could mean that the disease is either already present or about to come in that geography. So these are kind of early warning signals upon early warning signals. And then you want to look at things like what deserves your attention and what is really relevant to you, which again we spoke of earlier in detail. And you also want to be able to query it efficiently, and you want your models to retrain themselves on the data that you give it, so that the quality of output keeps increasing incrementally. And you don't want it to stagnate at a point where no matter what comes into the system, it all looks the same to you. The quality should ideally increase over time. So that is another layer that gets added here. And if you want to have a look at what our interface looks like, there's a screenshot here on the left. And if you look at what exactly is covered, one thing is all these articles that the users see are color coded. So red articles, of course, signal more grave incidents, either based on the sentiment or the severity, or a mixture of both. In this case, you can see the article that speaks of a death toll related to measles is shown in red color, because it is of a higher severity compared to, let's say, rains coming in or a minor outbreak coming in. So this just ensures that visually you're able to immediately identify what is of importance and what isn't. And of course, now we live in an age where synthesis of information is very, very easy and is at everyone's fingertips. So with the advent of LLMs or large language models, we are able to get like information phrased in a way that is easily digestible to us. Whereas earlier on, it would be dependent on people who build these platforms to customize it in such a way that it is easy to consume. But now you can go a level deeper and you can look at it in a way that is very specific to you. So let's say I want to query the data that is available. I can specify my question in such a way that only I ask it in this way, and maybe someone else would not be able to give it to me in a platform that is already built by them. So I think public health teams would probably be able to provide more insight into how exactly they use this data. But we have certain chatbots or reports that we provide to them that they can dig through, and they can see, they can look at certain nuanced perspectives of the same information. And that allows them to basically take it a step further compared to what the layman can derive from this data. So we'll just also touch upon the public health use case in slightly more detail. Uh, so event-based surveillance as a concept for CMS at least started a few years ago. And this is the entire project that we were covering so far. But since then, it has adapted to multiple other use cases apart from public health as well. So if we were to look at some of the things that show up, of course, this we just walked through it, right? But It also looks, you would have seen in the screenshot, there are also information about climate related events. And this is also something that you use to see certain diseases are associated with certain climates. So the fact that that climatic event is occurring tells you that something is going to come regardless of whether it has happened already or not. Um, and one thing you want your public health teams to see is that you don't just want to dump all information on them and leave it to them to filter it out. So this intelligence layer also clubs certain articles together such that repeated articles are not shown to them because they've already seen it before, so they can focus on what really matters. So some of these points we just looked at. So defining the universe, removing the noise, structuring the signal, etc. All crucial components of this entire system. And if you want to look at it in a slightly more expanded way, one is you collect the articles from the actual sources, filter them as I mentioned, extract important information and translate as I mentioned, and you also generate a summary for them. So instead of them having to read through the entire article, they again prioritize the important concepts of it and are able to filter through articles at a much quicker pace. And along with that, you also analyze them by the disease location, etc., which we will see a few examples of going forward. Okay, so this is a little more information on the filtering process. So we have two phases of filtering. The first phase basically removes the noise, and the second phase enriches the data. So if you want to look at what the noise removal process looks like, we look at articles that we are looking for. So let's say broadly in the range of public health or broadly related to the signals that we put out. And the second phase looks at out of these articles that are there, what kind of information are they conveying? So, for example, are they conveying information about a suspected outbreak, something that may occur, or something that has already occurred, or a confirmed outbreak? Is it general information? So, at times you will see doctors or hospitals or uh, medical organizations, they put out information that is just purely information that is not really related to something that's happening presently. It could also be something that they suspect is going to happen in the near future. So maybe they are being proactive in putting this information out so people know how to act. But regardless of the reasoning behind them putting out that information, it is basically a different category of information altogether. And apart from that is the climate component that I spoke of. So this also helps teams look at maybe things that they want to prioritize in terms of, let's say, they only want to act on things that have immediately occurred, confirmed outbreak. And others, the other three categories you'll see are more proactive in nature. So that depends on what your program is catered towards. But essentially, you have the option to prioritize both. So named entity recognition is also one of the key components of this system. So it's called NER for short. This basically looks at, of course, now we look at the public health use case, but in different contexts, it looks at what are the actual players or what are the actual components involved in each piece of information. So in our case for public health, it's going to be disease name, it's going to be locations, it's going to be symptoms, etc., which we spoke of. And it is also going to look at things like case count, etc., deaths, how many people were admitted to the hospital, and how many people sometimes even recovered from a disease. You also want to keep track of recoveries also and other kinds of evidence like that. So this is done through a few different approaches. One is you have models that you use, which are language models, not quite the same as large language models, but different kinds of language models that you train to identify these entities based on where they are placed in the text. And also, we built a few custom models to identify things like case counts and numerical evidence because the way they can be formatted in text is very hard to pick up just by using large language models. So these models we combine in a sort of a hybrid approach to get the exact entities and in this case also case counts and things like that. So this entire architecture, if we take a look at the not only the modeling part of it, which generates the insights, but also things like the view layer or the search layer, etc., or even the storage layer. We use a few different technologies under the hood which enable this to happen. So one is you will see a NoSQL mentioned over here, and for those of you unaware of it, SQL is a structured kind of a database, whereas NoSQL is an unstructured database. To put it on a very high level, so NoSQL basically allows us to capture these insights wherever they exist instead of mandating that certain kinds of things we will capture no matter what. And basically, what that allows us to do is tailor each insight to the article itself rather than to the program. And what that means is you are not forcing your insights to follow a specific format. You just allow whatever to emerge in the data so that you are not confining yourself to a limited scope of things that you're looking at. And then you have something called a semantic search and a vector database. In this day and age, I'm sure at least you may have heard a passing mention of these things. But essentially, what a semantic search does is it looks at what you're trying to ask rather than focusing on what you're exactly asking. Um, and of course, this has its pros and cons. But if you go to Google, for example, Google is one of the pioneers of keyword search. So based on the keywords that you type in, it gives you relevant results according to that. Whereas semantic search looks at this is my query, and this is what I mean by this query. And these are answers that, even though they may not exactly match the keywords that you type in, they are related to the keywords that you type in. So if I say things like a vector-borne disease outbreak, it can also capture things that broadly fall under that rather than looking at articles that mention the words vector-borne and things like that, right? So basically, it allows you to query your data better and see what broad scope of things that are there. So on our specific search layer, we combine keyword search and semantic search so that you're getting the best of both worlds. But these are basically the options that you can use to enhance your output from your search. And then if you want to look at what components make up an individual article, one example is what we put out here. So this specific article, if you see, conveys not only disease information. So usually, since Ebola tends to be a scary disease, uh, what medical organizations or news reports often do is, along with a summary of what has happened, they also mention what Ebola actually is and what kind of people it affects, or not people it affects, but what kind of effects it has on people. My bad. So this is a very concise way of showing what we have in one single article, so that you're not overloaded by information. But each article, if you look at what we capture on the back end, I think there are around 20 or 30 keys for each article. So 20 or 30 individual components of each article that we're tracking, which we then use to synthesize insights. And one example of those insights is the map that you see on your right, which basically gives you an overview of what kind of spread a particular disease has across a particular geography. So in this case, we're looking at India. And because we geocode these articles based on the locations mentioned in them, we are able to pinpoint, at least on a high level or on a district level, uh, what kind of articles are coming up, in what frequency, in what numbers, what kind of case counts are they mentioning, etc. And that gives you a visual overview to narrow down in a much easier way. So if you look at the green bubbles on the map, they are an indicator of maybe smaller scale articles. And the big red bubble that you see, that indicates that something is not normal here. Something is going so far from what we are used to seeing, at least in this particular time frame, that it could possibly need immediate attention. So another component of the articles that come in is also validation and verification. So you can also club these sources of data that you get with, let's say, vetting them by the sources on ground who have access to real data. So this could come either with collaboration with government entities or other platforms or partners that you work with. And you can basically validate in real time whether a particular report is accurate or not, and then choose to respond based on that. So this also ensures that you're not falling prey to sensationalism that news agencies often follow, uh, which is basically amplifying the severity of a particular event based like because it benefits them on a personal level. So here you make sure that you only act on what is actually happening and don't fall prey to all these things that are prevalent. So governance is, as I mentioned, validation and verification is a part of governance, but this is also a very crucial component of event-based surveillance in general, where you also feed back into your systems the real-time data that you get on the ground, so that your systems are in general better at identifying real signals compared to noise. And of course, you are able to act on it in a much more precise manner. So, if there are any questions, we can take them. And some of the questions, by the way, that we have addressed while designing these systems are on different levels. So, one is we look at what kind of things do we want to capture, what should we monitor on a very low level. And of course, our public health teams answer most of these questions on there. And so that's all on them in terms of what kind of report should be put out or communicated to the public, and what is just maybe something that is a one-off occurrence, and what really deserves action, etc. And I think before we move on to questions, I think Prerak would now take us through different applications of this event-based surveillance in different contexts.
Yeah, thanks, Sachin. So I think, yeah, what Sachin was trying to sort of explain was largely around how this entire event-based monitoring slash surveillance works in public health context, right? And when we look at the approach, we can also expand the application across different domains, right? Because whatever is relevant for public health can be also relevant for, let's say, child protection. So I'll give an example that, let's say, in a place like uh, district in Rajasthan or Uttar Pradesh, we know that certain reporting of child protection abuses or exploitation happens in a news media. Are we able to track, say that okay, things are changing or not over time, right? When you are implementing any program. So if as I program, if I'm running running a entire districts wide program, I would want to know whether my program is effective. Certainly, there are ways to do it in a M&E way, but let's say if I'm running it and trying to understand whether it is leading to decrease in child exploitation cases or not, right? That is one way to look at it. It's not a perfect way to look at it because certainly there are biases that would be there, but at least one way to indicate that okay, things are improving or not. Likewise, there are other use cases in livelihoods, governance. Recently, we have been trying one use case in the animal-human conflict as well, right? So whenever there is a animal-human conflict, it gets reported in different news media or social media, the local newspapers, all of this, right? So what we are trying to sort of indicate is that the application of the same system can be cross-cutting across different sectors, and it also has a merit because the underlying architecture still remains the same, right? So the idea is that okay, if we are able to take it to other sector, what can it lead to in terms of the real-time monitoring? Just a second, I think Sachin, you're presenting. Yeah. So what it leads to, right? What type of decisions it leads to, and how can it sort of enable various monitoring system? So let's say if we take an example of human-animal conflict in a specific use cases, the same approach was used there to understand, okay, what are the places under the focus area of few states that the program is working? Are there any incidents that are getting reported along with the programmatic inputs that they are giving, right? Are there any specific corridors which are getting mapped based on this incident getting reported? So all of this becomes available for programmatic monitoring for them to act on. And since this near real time feature of the entire event based monitoring tool allows them to keep acting on it in a more reflective manner. So let's say if I know that one case has been reported in another village, I'll probably start acting saying that okay, there might be more cases upcoming in the same region, right? Can I plan my programming strategies better? So the whole idea of this entire event based monitoring is that how do we make a particular uh, monitoring or this intelligence layer which is specific to their context, right? So in the next slide we'll talk about okay, what are the specific contexts where we can tailor this thing. Can you make it the same public health if I want to track a Nipah virus versus if I want to track COVID, right? Both will have a very specific taxonomies of the way it gets identified. Likewise, the context in the way it spreads, right? Somewhere you would identify that okay, it spreads via vector-borne disease versus something. It could be a human-to-human disease, right? So, like that, a lot of these keywords, the context will become important when we start using this event-based monitoring tool, and all of this is configurable. So the scale also can be much higher than relying on a primary survey on the ground or a specific resource-intensive activity that we may need to do in a specific environment, right? So it allows the different programmatic teams to plan okay, where should they implement what. It even at the funder level or ecosystem level, it helps them understand okay, where are the different pockets which are emerging where the more investment is required to tackle certain societal problems, right? So the whole idea of this entire tool is that okay, how do we ensure that certain social problems can be monitored via some of these tools, right? So probably when we go back and try to understand for more programmatically, there are a few questions that we can all collectively reflect on. So the idea is that okay, are there any specific events that we would want to continuously monitor, right? In the next slide, I think Sachin will show that as well. What are the places where some of this can be more relevant versus not, right? Certainly, when we want to establish the attribution or causation, probably the gold standard like RCT might be the best choice. But in a places like where having a right signal to at least influence the policy or probably programmatic strategies itself is enough, then probably the event-based monitoring sort of a tool might be more useful, right? When does this signal or intelligence becomes an alert for program? What is the context that we are operating in? All of this becomes more and more nuanced as we start thinking the on the sectoral application of this particular tool. So that is what we had to sort of walk through in terms of our experience of last 4 to 5 years in sort of developing this tool and understanding application of this across the M&E work that we have been doing across different partners. Now, these are sort of some of the open questions that we'll leave it with audience as well. If they want to sort of reflect, okay, what are the type of use cases that they would want to sort of implement this tool, right? And how does this gets more nuanced for different public or programmatic sources or the data that we are trying to bring intelligence from? Specific questions from uh, everyone who are, has any comments or anything. If you want, probably you can put it on chat as well, and we will be happy to respond one by one each of them. I'll just wait for about another 30 seconds or 1 minute to collate all the question, and then we'll address each of them one by one. Okay, so I'll probably start taking one by one. And Saida, to respond to your question in terms of how do we identify and configure signals, right? So typically in the problem statement that we want to address and monitor, we define, okay, what is the decision that we would want to take. That's in the case of human animal conflict, right? We want to understand, okay, which are the evolving hotspot areas where this human animal conflict is emerging more and more as we see in the day to day work, right? Then the idea is that, okay, what are the type of signals that indicates that now, whether it's a conflict between human and animal, whether it's more about the deaths because of human animal conflict, or whether it's more about, let's say, the running over or the more of a development of new roads where there is a more transport available in the corridors where animals used to exist, right? So a lot of those defines on how signal gets picked up. Now the signals on where it gets picked up gets decided based on the again context. Let's say in few cases it could be local news media, in few cases it might be social media as well, right? Because a lot of these things has a relevance in the way it gets spread in terms of the information. So depending on that, we identify and configure the signals, and the keywords that we use are very specific in nature, so which allows them to pinpoint to say that, okay, because of conflict between, let's say, a human and any, whether even if it was not a death, there could be a potential area where there might be more intervention required, right? So like that we sort of configure that for different type of signals. I hope that answers your question, Saida.
Yes, thank you, Prerak.
Yeah. On Priyansi, your question, can event-based monitoring evolve? Yeah, certainly. So the idea of event-based monitoring is to also understand how the patterns emerge, right? So when we start looking at over 2 3 years of data and understand, okay, how does the patterns emerge out of it, we are also able to derive more predictive models out of it. Let's just say that, okay, COVID virus is spread in a certain hotspot or a pocket, and that is what we get to know from this event-based monitoring over time. Then we are able to derive that more meaningfully and statistically, saying that, okay, these are the drivers that potentially could lead to COVID spread in the future, right? That leads to a predictive monitoring as well. Certainly it's not a like 100% foolproof solution. There will be other drivers of the same disease outbreaks, but it can guide you in more predictive, saying that, okay, if the temperature is going to rise in the particular region, there is more likely that COVID will spread here. But how do you even understand whether temperature affects the COVID spread, right? So there will be enough articles saying that, okay, during the higher heat period, there are more cases being reported. Likewise, during the higher air pollution, there are more cases being reported, right? So depending on the use cases, we can identify the patterns, and it eventually leads to the predictive monitoring as well. Any other further reflections or any questions from any of the other participants? So that I think respond to this question, I'll invite Sachin as well, because he has seen this entire cycle around how validation happens. There is a certain time lag; it goes through enough iterations as well. But Sachin, over to you for the details.
Yeah, thanks, Aida. That's a good question. So, in terms of the validation process, initially, at least from a technical point of view, it was a lot of annotation on our side to actually label what is accurate and what is not accurate. And we have that available for our public health teams to label the articles themselves as well. But in terms of what actually happens on the ground and validating whether the numbers are matching, things like that, that is much more of an on-ground effort compared to something that we can handle on the platform itself. So I think that is something that you can only find out once you're there. So from our end, we try to do more of vetting in terms of the sources, but not in terms of the information. What we can do is limited in nature.
Okay.
Okay, any other comments?
I have a question. Is the system itself is responsible for investigating a signal the moment it's fired?
Can you just elaborate that, Saida, a bit more?
So once a signal is triggered, right? Who is the responsible owner for the investigating that signal is like fired the moment it?
So this goes through a bit of validation in terms of where public health experts or any domain experts comes into play. So whenever there is a signal that gets triggered based on the patterns, it gets validated by these experts, and which eventually links to the communication that goes out to the frontline workers or relevant officials or the institutions. Now that the layer of human in the loop gets more and more, I would say, not required over time when the system is able to sort of ensure that the quality of that output or a signal is so good that the human validation may not be relevant after a few, let's say, iterations, right? Now that few iteration again depends on the context in terms of whether it takes a 6 week, whether it takes 8 week, or even more sometimes, right? So once it comes to that state, then that human validation is not required and that signal gets triggered. And what happens, let's say whatever we say that okay, there is a more likely of cases or conflict in the upcoming or this particular hotspot, you would also be able to triangulate that in the future with the new data coming in, right? Let's say I say that okay, there is a likely that this place will have a higher disease outbreak. I will be able to actually triangulate whether this had or not based on the same source of data that is coming in the system. So it triangulation in itself is what even Sachin was explaining, saying that okay, it basically learns on its own data as we progress and more data gets collected over time. Does that answer your question, Saida?
Yes, I think I have one more question. Mm.
Yeah.
Sorry, I'm asking more question on the signals because it is the start of this event monitoring. So how easy it is to add a new signal to the framework if a new type of risk or event is emerged?
Sachin?
Yeah, so the system is designed in such a way that you can add signals with relative ease. The only caveat is that once you add a signal, that's when the richness of the data starts to, be really high. So what that means is if I add a signal today, the data that I start collecting from today is of really high quality until I decide to stop collecting. But retroactively collecting that same data is a much harder task. So if I want to add a signal for things that have happened in the past, that is harder compared to things that will happen in the future. So that's the only caveat. But the system is, designed to handle new signals coming in with a lot of ease. So minimal effort required in the signal part. That's it.
Okay, thank you.
Okay. So I think we don't have any other comments or question. Okay, I'll take it as a yes. So thanks a lot everyone for joining in, and I hope this masterclass was useful and you'll be able to take away something where some of this application would be useful in your regular M&E work as well. And hope to sort of see use cases of this particular event-based monitoring tool in different domains and by different organizations as well in future. So thanks a lot again for joining in, and thanks Sachin for facilitating as well. Thank you.
Thanks a lot. Thank you.
Thank you.